Okay, here we're talking about the quadratic formula, which everyone should have memorized by now, I would hope. It's if you have a quadratic equation, ax squared plus bx plus c equals 0, we call that standard form of the equation, then your solutions, you get two of them, are x is opposite of b plus or minus square root of b squared minus 4ac all over 2a. At the end of this video, I'll include a link to the song. I didn't do the song, but you can go watch the song and you can sing it along if you want. Keep in mind, if you're going to use quadratic formula, you have to be in standard form. You have to have your equation, simplify it over here on the left side, equal to 0. Okay, this piece here, underneath the radical, b squared minus 4ac, that tells us what kind of x-intercepts our function f of x equals ax squared plus bx plus c would have. Remember, that's what we're really doing, is finding the x-coordinate of x-intercepts when we're using quadratic formula. So this piece under the radical tells us whether we have two x-intercepts, one, or none. If this piece under the radical is positive, then when we take the square root, we get a real number. If this piece under the radical is 0, square root of 0 is 0, and we get a plus or minus 0, we get what's called a repeated root. And if this piece is negative, you can't take a square root of a negative and get a real number. We get complex or imaginary numbers, and we don't get x-intercepts. Okay, that's all laid out here. The discriminant discriminates between the different types of quadratics we have. It's b squared minus 4ac, and if it's positive, you get two real, unique solutions to the equation, and the graph has two x-intercepts. If the discriminant is 0, you only get one solution. It's a repeated solution, and you only get one x-intercept. And if the discriminant is negative, you get complex solutions to your equation, and the graph has no x-intercepts. Okay, so in this particular case, we would have a positive discriminant. We would have two solutions to the equation ax squared plus bx plus c equals 0. And this function, f of x, would have two x-intercepts right here, negative 3, 0, and 2, 0. And they're unique, they're different. Here's a case where the discriminant is equal to 0. That's when the parabola sits right on the vertex. The vertex is right on the x-axis. So the equation ax squared plus bx plus c equals 0 would only have one solution. This one in particular would have x equals 2 and x equals 2. The same solution twice. Call that a repeated solution. The graph only has one x-intercept, which happens to be the vertex, which it always will be, 2, 0. And in this case, we have a negative discriminant. That's when we would be taking square roots of negative numbers. Those do not correspond to x-intercepts. This graph has no x-intercepts at all. The equation ax squared plus bx plus c equals 0 still has solutions, but they're not real. They're complex solutions. And you can't graph complex numbers here in the real plane. Okay, an example of using the quadratic formula to get our solutions. Say we want to solve 2x squared plus 4x minus 5 equals 0. First we identify a, b, and c. A is 2, b is 4, c is negative 5. So we want x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over twice a. And then it's just arithmetic. Remember order of operations. 4 squared is 16. A negative 4 times a 2 times a negative 5 is a plus 40. And then 16 plus 40 is 56. Here are the solutions to this equation. X is negative 4 plus or minus root 56 over 4. That can't be simplified. The graph would look like this. Notice this graph points up. We know that by looking at A. A tells us if the graph points up or down. A is positive 2, so the graph points up. Those x-intercepts, we had 2 of them, are here. Those x values are these 2 different x values here. Of course, the y values are 0. X-intercepts always have y values of 0. Okay, here's another example. We're solving x squared plus 10x plus 25 equals 0. A is 1, B is 10, C is 25. Remember, A, B, and C are just numbers. They don't have x's in them. You'll never have any x's written over here inside quadratic formula. So we plug everything in, and we get under the radical 100 minus 100, which is 0. So we get negative 10 plus 0. That's negative 10. Negative 10 minus 0. That's also negative 10 over 2. And of course, negative 10 over 2 is negative 5. We get the same answer twice. That means on the graph, x equals negative 5 is the x-coordinate of my x-intercept. The x-intercept is negative 5, 0. The solutions to this equation, there are 2 of them. Quadratics always have 2 solutions. They just both happen to be the same number. They're both x equals negative 5. Okay, that's a case where the discriminant was equal to 0. Here's another case where the discriminant is negative. Now we'll get a negative under the radical. So here A is 1, B is 4, and C is 6. That's a typo right there. That should not be a negative. So ignore that negative. We get x equals opposite of b plus or minus square root of b squared. This should just be 4 squared minus 4 times a times c all over 2a. Under the radical, we get 16 minus 24, which is negative 8. Square root of a negative gives us an I outside. Square root of 8, you might remember from simplifying radicals, would be 2 times square root of 2. So our final answers are x equals negative 4 plus or minus 2i root 2 over 2. 2 solutions. Quadratics always have 2 solutions. These 2 just happen to be complex, so the graph will have no x-intercepts. Okay, that is quadratic formula. Click on any of these videos to watch related topics.